All right, this is the last section of the test. It says here another pair of parallel plates is connected in series. State the effect on the total capacitance. If you connect them in series, the total capacitance decreases. Explain your answer. Voltage will be shared between capacitors and the charge on obeys. Q total is equal to Q1 is equal to Q2. So the equivalent capacitance can be expressed as C total is equal to 1 over C1 plus 1 over C2, all inverse. So C total is less than C1 or C2. Okay, that's perhaps not the clearest answer in the world, but that covers all the bases. Okay, a resistor-capacitor branch of the electron gun has a time constant of 4.2 milliseconds. The maximum voltage supplied in the circuit is 5 volts. Sketch the voltage V versus time and current versus time graph. Use the data supplied above to give two values on each of the axes on the voltage time graph. Okay, let's see if the smartboard is going to let me do this. So this maximum voltage is 5 volts. No, it won't let me draw on top of this drawing. Okay, so I'll just explain. We should have an asymptote along here, which is 5 volts. And then we should have a value along the bottom here, which is the time constant. It won't let me draw on top of another drawing, so maybe I'll do this on a separate page. Yeah, why don't I do that? So I'll go File, New, Blank Document. So I'll go like this. Oops. View, start inking. So it'll look like this. Here's voltage, here's time. We'll have 5 volts here, and the voltage will rise approaching that asymptote. And after one time constant, here, which we said was, let's have a look. Let's go up so I can see the data. 4.2 milliseconds. Oops. Pen 4.2 will get up to, so this is 0.63 times 5, and then after 8.4 milliseconds, not micro, milli. Let's fix that. It will have gotten up to here, which is 0.63 times 5 plus 0.63 times 5 minus 0.63 times 5. Okay, so it's basically 0.63 times 5 plus another 63% of what's left is going to take us up to this point. Okay, so that's the voltage time graph. We then asked to do a current time graph as well. And with the current time graph, we're going to get initially a very big current. So we're going to get a graph that looks like that. Hey, let me draw it. Okay. And it's going to decay away because as the capacitor fills up, it's going to oppose the battery more and more, which is going to reduce the current more and more. Okay, and for that one we didn't need to write in any working. All right. For part F, in another electron gun, a part of the circuit has a resistance of this and a capacitor. And here we're shown what happens after the first time constant. So here we're asked to figure out the capacitance. Well, we know that we're given tau. It's not letting me draw here at all. I have to do it on the margins. Tau is equal to RC. So C is equal to tau over R, which is equal to, we've got 560 milliseconds. So that's 0.56 over, and we've got 120 kilo ohms. 120,000 is equal to, and we can work that out, 0.56 divided by 120,000 is equal to 4.7 microfarads, because it was 4.7 times 10 to the negative 6. Either answer is fine. Okay, so that's the end of the test. If any of these things are hard for you, you really need to just practice it, because once you've done each type of problem a few times, it will become much easier for you.